exponential functions. For any real number x, an exponential function is a function with the form f of x equals a times b to the x, where a is a non-zero real number called the initial value, b is any positive real number such that b cannot equal 1, and also b is called the base, just so you know. And the next one is the domain of f is all real numbers, and the range of f is all positive real numbers if a is greater than 0, and the range of f is all negative real numbers if a is less than 0. And also we have here the y-intercept is 0a, and the horizontal asymptote is y equals 0. So these are just a lot of conditions that we have for this exponential functions, which are just the whole type of problems here. I got a problem to the right here. It says graph f of x equals 2 to the x. And all we're going to do is graph this. So the best way to start with this is an xy table. So then when I plug in 0, actually, should we go negative? Let's go negative 2. I'm going to double this column here. So I'll start at negative 3, and then negative 2, negative 1, 0, 1, 2, 3. Maybe I should put a 4 in there too, but we'll stop there. That'll be enough. So that means when I plug in negative 3 in there, so I'll say x equals negative 3, and that's going to imply we get 2 to the negative 3, which that flips the exponent to the bottom. So it's 1 over 2 cubed, which is 1/8. So it's going to be 1/8. And then the next one's going to be 1/4. And then x equals negative 1. It's going to be 2 to the negative 1, which is 1/2. And then anything to the 0 power is 1. And then 2 to the first is 2. 2 to the second is 4. And 2 to the third is 8. Okay, so that's enough values to kind of get an idea of what's going on here for this graph. So I'm going to use a different color here. I'll use a purple this time. All right, so we're just going to plot these points. So at negative 3, it's 1/8, so just above the x-axis. And then at 2, negative 2, it's 1/4, so it's a little bit higher. And then at negative 1, it's 1/2. Oh, I got the wrong function on there. All right, let me go back. Okay, now I got it. So at 0, it's 1. And then at 1, it's 2. Then at 2, it's 4. Fix it. And at 3, it's 8. All right, so we see what's going on here. Hopefully you can see the function already. It does this. That's our graph. And that's what we call an exponential. And if we wanted to call it a growth or decay, that would be a growth because it's increasing as I go from left to right. So we have a decreasing as well. That means it would drop. And we have variations of this. Now let's take a look at some of these conditions that it actually talked about in here. Like for instance, the horizontal asymptote at y equals 0. And now we can see where that I would have this horizontal asymptote at y equals 0. And where a was greater than greater than 0, what we see here is it says then the range is going to be all positive real numbers. So it's going to be increasing. So therefore it's going to be going upward. All right, cool. So this is a nice little graph to kind kind of get used to what these exponential functions are going to look like. Now, they're always going to look like some sort of swoosh. And the way to tell exponential functions in general are these horizontal asymptotes. So that's one way to notice that, because we're going to talk about logs or logarithmic functions in a little bit, so it's important to try to understand that it's really the horizontal asymptote that really makes these exponential functions stand out. And also look at the initial value, and that's where my x equals 0, and where x equals 0 at, I get a 1. And if you look at the number in front of the exponential, you don't see anything there, so it's understood to be a 1. So really it's 1 times 2 to the x. All right.